Okay, so here we are given the graph of f prime of x. We need to keep in mind what graph we're being given, f prime. So to find the intervals of concavity and points of inflection, I need to know what the graph of f double prime looks like. So f double prime, so if I'm looking at where f prime is increasing, so where f prime is increasing, that's what f double prime will be positive. So f prime is increasing up until 0, so that means the second derivative graph is above 0, a positive, above the x-axis. So f prime increasing means f double prime is bigger than 0. All right, so f prime decreasing, remember you read a graph like you read a word, coming down, so between 0 and 4, the second derivative graph is below the x-axis. F prime decreasing means f double prime has got to be less than 0. And then the second derivative is increasing, or the first derivative is, the graph is increasing, so that means the second derivative graph is above the x-axis. All right, so we're just looking to find place in between where it looks like between 0 and 4. I tried to make it symmetric, so it looks like around 2 that it would be in between. All right, so where is the function, the f of x is concave up when the second derivative graph is above the x-axis, so that would be negative infinity to 0, and then from 4 to infinity. And the function would be concave down when the second derivative graph is below the x-axis. So that's between 0 and 4. Remember, we're not looking at the shape. All right. And the points of inflection would be the x values where it's changing concavity. So that would be at 0 and 4, because before 0, the second derivative is positive, and then it's negative. And at 4, the second derivative is negative, and then it changes to positive. All right, let's do the same thing for this one. So it is not necessary to draw the second derivative in this particular one. You could have gotten the information just from looking at the derivative increasing and decreasing. On this one, it could be helpful to have the graph, so it's up to you of how you wanted to come to the conclusion with your answers using the second derivative. All right, so first I'm asked to find where there are local extrema. So local extrema, they happen at critical numbers, right? So let's go find the critical numbers. So that's where the derivative equals 0 or the derivative doesn't exist. So looking at this graph here, oops, I neglected to label this point. So let's label this point -1. And let's label this point 2. Sorry about that. Okay, so you've got a graph here, roughly sketched out, so get that on your paper. So critical numbers happening at x equal -1 and 2. And there are no critical numbers where the derivative doesn't exist. So those are the only two critical numbers, and that's good because the second derivative test can only be used on these kind of critical numbers. All right, so now I need to find out what the sign of the second derivative is at these numbers. So looking at this graph here, when the derivative is decreasing, that means f double prime is less than 0, right? That's concave down. All right, so if I look at this graph here, it's decreasing all the way to 1. So f prime is decreasing between negative infinity and 1. So that means f of x is concave down on that interval. And then I see the function is increasing. F prime is increasing between 1 and infinity. So that must mean that function is concave up. All right, so combining these pieces of information, so I'm taking my critical numbers, so I'm thinking about what the sign of the second derivative is at -1, and I see that the derivative is decreasing, so that's going to be less than 0. So combine the f prime of -1 equals 0, combined with the second derivative at -1 less than 0, I get in my mind, I get this picture of slope 0, concave down, so therefore f of -1 must be a local max. All right, so now let's go check out my other critical number. So my other critical number is f prime of 2 equaling 0. So I'm interested in what the sign of f of the second derivative at 2 is. So the second derivative at 2, I see that the derivative is increasing, so that means the second derivative is going to be positive. So in my mind, I'm looking and thinking slope is 0 and it's cupped up. I can see that f of 2 must be a local minimum.